Good morning, students. Today I am talking on the subject of technical textiles, scope for professionals and entrepreneurs. See, this is a very important subject in technical textiles because technical textiles is coming very fast in foreign countries like USA, Germany, China. It became slightly late in India due to lack of research and development, and people are adopting it late actually. They don't want to take the risk. But if they take the risk, there must be a huge margin of the profits. Now, my question is that why we are taking education, or why parents are spending so much money for their children education. I just put a small Sanskrit shloka. Vidya dadati vinayam, vinyat yati patratam, patratat dharmapnopti, dhanat dharmam tadasukam. It means from education we are getting humility. Vinyat yati patratam. Humility gives the ability. Then patratat dharmapnopti. Ability gives the wealth and money. Dhanat dharmam tadasukam. This best for us and best comfort for the others who are in surrounding. So education is so important, and I feel privileged to say that International Institute of Textiles Management and Technical Studies arranging the courses which are really job oriented in present era. So technical textiles were very important part of this. So please listen me very carefully on this subject. Now we are going on the subject. If you see, what is entrepreneurship? See, entrepreneurship is the process of identifying and starting a business venture. First, we have to see the sources, then organization, then one committed entrepreneur take the advantage of the entrepreneurship and even afford the losses due to this. So this is a very careful process to start entrepreneurship. Now, in technical textiles, again, if we see any business communication skills are very important. First, we have to plan some task. Suppose we'll make one product which is demand is more, or we'll make one product demand is less, but it cannot be obtained anywhere near the requirement. Like that, there are so many examples are there. So we have to plan for business. Then after plan, we have to do the exercise on this product definition. Then we have to do on that initialization of the project, what is required raw material, what is transportation, how much the labor is required, what is costing, this kind of project actually. Then again check it. After doing all this steps to plan and do, we have to again check it, like carpenter rule, check twice before cutting. Once we cut the thing in two pieces, we cannot do anything. So before cutting, we have to check in 2 times or 3 times or several times before taking any task. Then act on that. Now every task is a project. For example, I want to start a business of fabrics. So this is a project. Yeah, I will make the shirts. So to make the shirts, we have to see the project conception and initialization. If for making this shirt, just I'm giving the example of shirt actually, any project. We have to first see the conception, what is required for shirt. Threads are required, fabric is required, particular variety of fabric is required, Then buttons are required, the collar is required, tough cotton is required to put inside, ironing is required, finish steam ironing is required, then packaging is required. That way we can initialize the project. So after segregation of these things, we have to go by definition. For each and everything we have to define well. Then we can execute the project. After execution of project, performance we have to monitor and control. What is the specification? What are the parameters? Whether they are coming or not coming. If not coming, why not coming? If coming good, how can be maintained for better quality and production? Then after a certain requirement fulfilled, we have to close this particular project. So then again we have to make the sari, then again we have to make the dress material, then we have to make the trouser. So each one is a one project, and number of projects will make a factory, and the person who is handling these things at topmost is the entrepreneur, who is well educated and well experienced, and giving the job opportunities to several persons in the country. Now, I coming on the subject, technical textiles. Basically, technical textiles has a 12 segments, but if we go on important segments, demand is in automobiles, agrotech, protech, mobile tech, then pectech, then meditech, then geotech, the industech, then sport tech. I will go in details on the each one actually in next slides. If you see the automobile textile industry, auto hose fabric, then automobile interior carpets, automotive airbags, car upholstery, car body, even bulletproofing of car, everything comes in technical textiles. There is a lot of scope in this industry. If you go on geotextiles, we can see geogrids, geomats, geomembranes, geonets, non-woven geotextiles. There are many items which are daily required in the construction of geo industry and rapidly used in even India now in mass quantity. Then medical textiles. A lot of contribution of the medical textiles. Suppose baby diaper, bandages, contact lenses, gauzes, gowns, inconvenient diapers, mask. Mask, if we say, I am giving one example of an institute, Atira. In around 6-7 years back, there was swine flu fever came, and no mask was working properly, and impact was much more of the swine fever. Even it goes up to the death of the people. So Atira invented a mask guaranteed for 99.9% breathing, and it has worked very good. And they distributed this mask free of cost for the social welfare. So there are a lot of contribution in this in medical textiles. Then if we go on non-woven textiles, we can make air-laid, carded, chemical bonded, composite, melt brown, needle punch, spun bond, and spunless fabrics. So many. Actually, non-woven industry was failing some years back because machines are usually used conventional, even China made or local made, and they give the huge production. The requirement of 1 week can be covered by 24 hours duty in 2-3 days. Then labor is free. What to do with the labor? Because you see, if we see the main machine and material, main is the very expensive asset. We cannot lose it actually. So they have no job after this. But since this technical textile has come, there are some processes which I show you in the next slides. The value addition on non-woven has been increased, and people are engaged for a whole year in the factory. Now, if we go on Octech textile, we have to see the industrial hazards, waste disposal products, the concept of green dustbin and blue dustbin. Other optech applications comes under optech industry. Then agro textiles, agro bags, NTL nets, which prevents the crop. Then bell wrap nets, belletin, bird protection nets, crop nets, fish linings. This comes under agro textiles. So you can say there are a lot of items which comes under now textiles in technical textiles. So one person has a lot of scope to start the business of his attitude as well as requirement in the particular area. Now, protected textiles. There is a tremendous contribution of protected textiles for you can see the chemical industry, then you can see a defense, ballistic protection fabrics, bulletproof jackets, chemical protection clothing, cut protection fabrics. Suppose people are doing some cutting business with a knife, they have the hand glove, so organ cannot be come in the contact with this knife actually. Then packaging textiles. As I told you in non-woven, packaging textiles are a huge revolution with the introduction of the lamination and coating. After lamination, we can give the value addition to non-wovens. Then we can just laminate them with the BOPP, biaxially oriented polypropylene. Then we can print it. It will become the export quality bags as per requirement. Then if we go on clothing textiles, these are mostly narrow fabrics, elastic narrow fabrics, hook and loop, tape fasteners, interlinings, labels, swing threads, shoe components. Here I want to add one thing. If we are talking about the narrow fabric, it comes in idea rope and belt. Now, previously ropes are coming of conventional time by just braiding, like three or more than three fibers interlaced together, producing the braided rope. Now, rope can be made by weaving also, and they have the core and sheath arrangement. Core is inside material and sheath is outside material. Because of core, strength of rope can be ascertained, and because of sheath, aesthetic property like handling of the rope can be ascertained. Suppose inside we put the carbon, so strength will come because of carbon, and outside we are putting the cotton. So we can just hold it properly by the naked hands, no problem. So this is the then belt. There are several belts we are using, industrial belts, and there are woven belts also. Then raw material textiles. The basalt fabric, bicomponent fiber, carbon fiber, ceramic, coir, these are the raw material textiles. Then export textiles. There is a good contribution in the export industry also. Artificial tuft, ballooning fabrics, boat covers, climbing ropes, as I told you before, paragliders, parachute fabrics, sail nets can be made by the export textiles. Then building textiles. Architectural membranes, ovings, canvas turbines, concrete reinforcement. These are the main products and they are usually in production under technical textiles. Then home tech textiles, carpet baking cloth. This lino cloth I will show in the next slides with polyester. Then curtain tapes, fiber filter fabrics for vacuum cleaner, furniture fabrics, etc. We can make in the home tech textiles. The industrial textiles, abrasive fabric like sandpaper, absorbent glass mats, battery separators, bolting cloth, thick cloth which can hold and some bolts can be fitted for separation, cigarette filters, coating is done by industrial textiles. Then if we see scope of technical textiles, naturally you have seen the list of products, even this is a very small list, we can multiply it if we go on the broad manner. So technical textile is naturally much more, and according to requirement of the particular field, we can start the business. Entrepreneur can start the business, and naturally, one can do this business secretly and maintain the good unique sales price. And if somebody makes the good unit sales price, naturally loan profit margins are more, ROI can be shorter by this way. So this business is very effective and profitable. Now, basic yarns of the used in the technical textiles are basic glass fiber, aramid fiber, carbon fiber, and their chips. Now, dynamics also come, but it is not much of it is in rare use actually. Some companies are making the dynamite like DSM, then Tejan is making, DuPont is making like this. Now, this was the description of the products. Now, technology. If we come on technology, in textile naturally, there is a process of combining the warp yarn and weft yarn according to fabric construction. So, there are 8 methods in weaving can be used to generate technical textiles. So, just I am talking about the names of the weft insertion rates. Then I will show the loops in the next slides. One is the peptide technology, where the weft yarn is transferred by the steel projectiles. Then rapier technology, where the weft yarn is transported by giver and taker rapier. This rapier may be flexible or rigid according to the variety of the fabric to be produced. Then water-jet loom technology. Water-jet technology, weft yarn travels by the jet of water. Mostly polyester we are making on this technology. Then air jet technology. Air jet technology where weft yarn travels by the air, jet of air. Now multiple weaving technology. Multiple weaving technology is circular type weaving machine or flat weaving machine, and in the several shade of warp, several weft can be inserted in this technology. Then multi-axial weaving technology. Multi-axial fabrics are required for the strength, so we can make the multi-axial weaving technology. Then go for further process like lamination and coating. Then weaving machine and embroidery units. Embroidery everybody knows actually, and there is a lot of scope in the embroidery and decorative fabrics. Then needle weaving technology for narrow fabric and ropes. Now there are the narrow looms. There are some local looms also indigenous, and main looms are made by very initially Switzerland. These are the Jacob Muller belt narrow loom, then Jacob Muller rope narrow loom. So we can produce several type of ropes and belts. Then three-dimensional 3D weaving. 3D weaving have a lot of significance and use. This is mainly used in the automobile industry, aeronautics, and other industries. Now, first we are coming on the soldier picking mechanism. Soldier picking mechanism where the weft yarn is traveled by a projectile. A projectile is made of the small cross-section steel 90 mm long, 50 mm wide, and 6 mm thickness. Several projectiles in the shed travel and they carry the weft yarn to make the fabric. And a sharing strain energy just gives the bit of force to projectile and picking takes place. This is a good mass production loom. I can show you one weaving on this process. The polypropylene ventilator fabric weaving on soldier projectile weaving machine. Soldier looms are were very good earlier. Now even right now they are using it. But since microprocessor based control looms has come, more information we are getting. Soldier looms are now less. But for particular segment of heavy fabric, we are using the soldier looms. Like you can see this polypropylene ventilator fabric. If you see, this is fabric, this is slot, this is fabric, this is beft slot, this is fabric, this is a beft slot. So if you make a carry bag, what will happen? This carry bag will be perforated. If you transport fish from one place to other place, you can transport the live fishes in fish industry. If you want to transport the fresh vegetables like tomato or potato, you put in this bag, they'll get the very good oxygen. So this is the advantage of this ventilator fabric. We can make many things on like this actually, and mass production is required. Then repair looms, as I told you. The repair loom system of BEFT is known as the first successful practical basis for mass production. And this BEFT is transferred by these two grippers. The one is giver and one is taker. BEFT runs from one side. It brings the thread, it gives to other, it takes back and beat up takes place. Consequently, fabric produces according to design. What we fed in the Dobby looms or maybe in microprocessor methods like this and jacquards. So the mechanism of the repair is very easy and these looms are very productive and mass production can be taken from these looms. Even any type of yarn, even waste yarn can be run very smoothly by these looms actually. The demand of repair looms is highest this time for technical textiles. Then if you see these repair looms, these are the Dornier repair looms. You see there are many companies. If you see Germany technical textiles, they are using on Dornier repair machine. If you go on Belgium, they are using Picanol repair machines. If you see in other things like Alpha PGA and Somet repair looms, they are again other repair. So that way, according to need, according to country, they are using these looms for technical textiles of different manufacturers and different facilities. Now, I am showing you here the carbon weaving and aramid weaving on rapier loom, Dornier repair loom. This loom, we are making the carbon fabric. You can see here the special arrangement. There is no beam for carbon. Straight threads are coming and they are just making the fabric. And this carbon is very dangerous for the health who are producing the carbon. I show you this next slide. I come back on this slide. The person who is operating this machine wears the protective dress actually. So the carbon fibers should not touch their body. Even they use this face mask, then specs, everywhere they covered, gloves. So protection is very important. And if you see this carbon weaving, here you see this particular tilted fabric is producing. This is called a satin carbon fabric. This is useful for the niche segment like aerobatic aeroplane parts. Tilted parts like propeller of the aeroplane, where tilt, this type of fabric used. This is the costly carbon actually. 3K carbon, 6K carbon is the nomenclature. If you go in the other variety of carbon, this 24K, 50K carbon, it is used in the basically in construction industry. I show you later in this slide. Then again there is a UD carbon and BD carbon. BD carbon is bidirectional carbon. Means the yarn of the vertical and horizontal, means warp and weft, will go in equal or 60-40 ratio or 70-30 ratio. While in UD carbon, strength comes by warp yarn, longitudinal yarn only, and weft yarn we are using just for interlacement. So weft yarn will remain only around 10% and warp yarn we use the 90%. Because weft yarn has no role in the strength, it is just making the fabric by insertion. I show you in the application this thing. This is a Jacob Muller weaving machine. Australia. This is a Dornier weighing machine of Germany. They are most widely used in the NDI one in many industries. Now you see the use of the carbon fabric. It is dynamic use actually. There is the Airbus. We have used the lightweight technology having carbon. Carbon is more 8 times stronger than steel, and even aramid is 6 times stronger than steel like this. So in this aircraft, we have replaced the steel parts by carbon and aramid and glass parts. So 53% carbon fabric composite we have used here. Maybe hybrid, maybe pure. So due to addition of this 50% carbon fabric, this fuel efficiency increased by 20% in this aircraft. This is an innovation actually, cost effective. You see the carbon hybrid fabrics. If you see here, these are the basic weaves actually what design a weaver is making on the loom. First, as I told you in the project, initialization of the weaving, they are planning what we are going to do, then they are doing it actually. So they planned we will do it this way, we will take carbon by carbon, we will take carbon by carbon that way, we can take carbon by carbon plain way. Then we will mix aramid with carbon in a UD fabric. The weft is less and warp is more. Then we will take the aramid fabric maybe 50% or maybe 60-40% like this. So carbon is costly, aramid is less costly. So composite application by just determining the what strength required, we can make it more cost effective. Now you see the application of carbon fiber for building, for beaming in construction. Now you just imagine there is a building having 10 or 12 stories. So because of the load of the stories, it is just stand on the 4 or 6 square pillars. Around 10 years back we are using the square pillars. Now builders are making the round pillar also. So these square pillars with the time, say 50 years, 60 years, 70 years, because of the load and compression, extremities of the pillar just damaging, coming out. You can see, just imagine a building. If building is stand on the 4 pillar, you can see on the extremities there are the some injuries, materials coming out, and this building becomes risky. It may fall down anytime. So without removing the total infrastructure, we can repair the pillars. How? This is a carbon which we made, I told you earlier, on a narrow machine. The 24K50 carbon, not very costly. It comes around 2200 rupees per kg like this price. Then after this carbon they are cutting it here. Then after cutting, we are doing layering of the carbon fiber using epoxy. After drying, we are applying and we are taking the strength, final layer. So that way we have checked this in Atira and Nirma University Ahmedabad. Jointly we have taken this project and we have found tremendous of buildings can be repaired by this, and now it is commercialized actually. People are doing it. Like builders, we can say Goyal, then Anil Bakedi, then I can speak names, the Hirpara. Many builders have adopted this technology to repair the old buildings. Then use of carbon is very wide actually. Carbon and hybrid fabric, cost-effective composite applications. What we can see, as I told you this thing, we can make the carbon rings, we can make the half rings, we can make the Italian arcs, semi and full. This comes in the automobile and other industries. We can make the carbon rods for civil construction and artificial limbs in medical science. You know, carbon wearing is very less, abrasive very less. So it is now adopted firstly in the medical technology also, mainly for artificial limbs. They are making it. So this is a good contribution of the carbon technology in the medical field. Now we can see the segmental use of the different variety of the carbon. Carbon product variant and applications. We can see carbon roving, which is a just form of the number of fibers in roving form we are using in aircrafts. Then chopped carbon fibers we are putting in the building infrastructure to give the strength. Then carbon fabrics, these were composite applications. Carbon hybrid fabrics, thermoplastics, carbon sleeves for compounding. Then carbon tapes, marine industry and sports goods. There's a lot of scope is there. There are some very small examples I am giving you. This is a very vast field actually, and we have a lot of application of these things. Even research is in progress. How we can make the more utilization of this technology in future. Then now I'm coming on the glass fiber. As I told you, carbon glass and aramid in the beginning. Again, we are taking the Dornier loom of Germany. Now you are seeing here two types of fabric. One is the fabric like fabric, other is the perforated fabric. So this fabric, suppose we are making the PPGL, polypropylene and glass blend. So what happens if we take this fabric on calendaring for 100 degrees centigrade temperature? I give an example. So polypropylene will melt, but glass will not melt. So both will mesh properly, and they will make a thick surface. So we can make the container to carry hazard gases, hazard chemicals in industry. There are a lot of industries in India, even abroad, to use the PPGL fabric, and a lot of requirement is there. Then you see here, this is a lino fabric. If we talk about lino fabric, the perforated fabric, 10 mm by 10 mm lino, 8 mm by 8 mm lino, or we can have 6 mm by 6 mm lino. These are symmetrical shapes. Even you can take 6 mm by 10 mm lino, 6 mm by 12 mm lino, asymmetrical shapes in polyester or glass. Even other fiber if required. Some specific demand is there. So what happens? Suppose here we are taking the lino in polyester. So polyester lino widely used in the carpet baking fabric in carpet industry. If we use the glass here, this is for reinforcement. You see, backside of tiles, if we put this proper fabric of glass, suppose tiles footpath can be made for 10 years, life will increase up to 50 years at least because of this grip. Even in Uttarakhand and northeast, the roads were totally deforming during the rainy seasons. Now they put this fabric actually, polypropylene fabric, lino fabrics. So now roads are stable. So in construction industry and even bridge industry, there is a lot of scope of this lino fabric, glass fabric. Now come to next. For an entrepreneur, they are very important to see the demand ratio. Suppose his capacity or space is less in the factory, but demand in future perception is more. They have to choose the loom of the multiple length. Suppose here they are making the symmetrical weaving width 1, 2, 3. So machine is running same. So production is increased by everywhere 30, 100% actually. They are taking the utilization. They can make one length also, but the loss of this 66%. But if they take the full capacity utilization, naturally they have the advantage here. So this is very important. How to select the machine for particular task and what are the future prospects of the business. Now lamination and coating machine. See, lamination and coating, lamination is the process this adopted since 1800 BC actually, when you see this Miss mummies were there, uh, and if you see that time they are preserving the dead bodies. There was one type of lamination or coating. Since many people are using this, but nobody is knowing the much importance of this. But since last 20-30 years, this has been adopted very quickly for preserving the thing, for giving strength to the thing material, for giving value addition to the material, like in automobile textiles, like in protective textiles, bulletproof fabrics, bulletproof jackets for military, police, medical textiles, aprons. They should not catch the germs. Suppose they are making the polyviscose fabric, they are putting the coating on there, so germs should not come in the incentive care unit. Then industrial textiles, as I told you earlier, and sport textiles, then fashionable wears. Suppose there is denim fabric, they can join two denim fabrics to give the fancy effect and making the coat. Then home furnishing in furnishing fabrics. Now this is the preform for bulletproofing jackets. I'm talking about preform. Preform means this is the initial material for a final object. Suppose I have to make one preform for bulletproofing car. So what they are doing, I'm giving the example just roughly. We are using the hot melt coating. Machines are here. In India, 3-4 machines are here. One is in Atira, one is in Kusungar, one is in South. So there's machines are there. For solvent coating, lot of machines are there. In every city there are machines for solvent coating. But for lamination and coating, hot melt coating, there are limited machines. So this bulletproof car is very costly. So they are taking a biaxial aramid fabric and putting the AOPP both side 50-50 gram coating. Now they are sending this fabric in the forensic laboratory. So for requirement of, we are saying 6 bullets. So we'll just shoot from a particular distance by gun, particular size gun, 6 times fire. If it is not giving any hole or impact on the fabric, it is passed. Otherwise, it is not passed. So making this fabric is not easy actually, and this should be 100% foolproof before giving to the user. So this technology is slightly complicated, but we are using in even India. Then you see the very easy technology. As I told you, non-woven fabric. There are time I told you non-woven fabric scope was gone. People were afraid to bring the machines of non-woven. But now since this value addition of the non-woven concept has come, we are just lagging the production in this industry. Suppose this is an example. We are taking just fabric. We are taking the film, golden color, silver color. We are just laminating it, then doing printing. We can make the very good poly wax. Even export quality wax people are making in India. So this is the application. Now I was talking about the weaving. Now I am coming on the braiding technology. Because this technical textile is possible by weaving, braiding, knitting, and non-woven. 4 things. Weaving and non-woven I have covered. So if any question you can type here, or after this presentation we will comfortable to solve any question if there. Let me continue. So application of the braiding technology. See, braiding I defined earlier. The demand of the different technical braids keeps pace between the technical progress. The medical industry, automotive industry, aeronautic industry, they all, even these satellites, space application centers, they all require the braiding fabric. Because knitted and braided fabric has the strength rather more than weaving. Suppose one person makes the perforated fabric which I told you earlier, lino fabric, on weaving, it can be used on tiles or road bridges for giving the strength to the bridge. But if we are talking about the bullet train, weaving fabric will not work. We need either very good knitted fabric or braided. So in knitted fabric, strength is more because of the construction introduction of the thread with the animation. So in the automated textiles, monofilament hoses for the assembly of the electrical installation, electrical industry, overbraid electrical, telecommunication cable, isolating cables, fiber braids, they are the main. Then grand packing gaskets, braids and glass, fiber, ceramic graphics, then aeronautics, automobiles. These all are required this braiding technology. Braiding is a very complicated technology, not easy actually. And I will show you one machine. The machine is installed first time in India by Atira, Ahmedabad. This is a robotic radial braiding machine. Now, if you see here, these are the carbon small bobbins, lot of bobbins. And here is the glass bobbins. They have to make the hybrid fabric of the glass and carbon. Now, this machine is operated by the robot, not by men, because but there are multiple functions in a cycle. So men can be injured. So robot is doing all these things program. We are just feeding the requirement in the robot, and now they are making this final product for computer application, and the robot is doing the work. We are just seeing from the outside of the glass frames. So this is a robotic braiding machine making the three-dimensional fabrics for composite applications. Application of knitted fabric, as I told you, they are very cost effective, and like flexure banner, you can see everywhere standees are there, banners are there, advertisement, picture industry, film cinema, the institutes, then many applications, exhibitions, we are seeing banner. The flexure banner revolution has come with the knitting actually. With knitting fabric, they are doing lamination and printing on that. The flexure banners are very cost effective and they gives very good glorious matte effect. So these are very much in requirement. Now demand of lino fabric for railway tracks, as I told you, bullet train with PVC coating for braid construction woven fabric is being used with the heavy vehicle with fast speed. So this is the requirement. China is using this because China is the highest speed train in the world, which runs on 420 minutes per hour. This magnetic train, they have taken this technology and adopted this needed path of the coating. Then I'm talking about the rope. Rope is the narrow loom woven technology or braid technology. Now you can see the rope here. What happens? Rope, if we are talking about rope, we are just thinking about the commercial rope. One bucket is just pulled by the rope from the wall, or rope just we are using in the daily use. No. Like climbing, like military use, climbing a mountain. Then just for defense purpose. Then marine industry on ships. We are using the very dynamic ropes actually. They should not be affected by the water. They should not be affected by the other atmospheric and they should be very stronger. So to make them stronger, suppose inside material we are taking the glass, so outside we are keeping the polyester. So we can just hold it very smoothly, but inside is a very strong material. Then if we want to take more stronger, we can put particular bit of carbon. If we want more than stronger, we can put the dynamo yarn. Dynamo yarn is the highest stronger yarn of the world, spectra yarn. So these are the yarns we are making the technical ropes, and these things are under progress actually. People are doing work on that. Now, if you see this thing, the conventional rope than other rope. So if you take the thick rope of conventional, very thin rope of the technical rope can sustain the same 80 kg load actually. Then you see this Porter railway station in Ahmedabad, they're using these steps to hold to tie these bags, and they were just slippier actually. There are many times if they are going to train and they're walking, the suitcases are coming out. So we are given them the flexible technical ropes of the low cost, uh, and awareness come. Now they are using it, and they keeps the very tight, and they are happy now in working. That way, communication cables, these USB cords or any cords, we're using this technology. Now, if we see the woven versus bed rope strength by research point of view, so what we found, always woven ropes are higher in strength rather than bed ropes. How we estimated? We have taken the same number of threads, same material, same diameter of rope made from the aramid and rope made from the uh, other material, made glass, made carbon, other material. So glass we compared bread and woven, and their installed machine of US and other machines are US, which gives the their breaking strength. So what we found, always woven rope is in a particular segment is very high in the strength. Here you can see woven rope is just double its strength. It is same dimension, same specifications, but same material. But you see it giving the double strength, it gives the less strength. Then you see the belt. If we talk about the belt is highly adopted thing on the machines even. V belts, then flat belts, then other type of timing belts. Now with technical textiles, these are things which are making, but more than that, we are going with the high temperature belts. What high temperature belts? Suppose we have woven aramid belt or loom or narrow loom, as I told you. Then we are giving the particular chemical coating or particular GSM. So it can sustain 350 degrees centigrade to 1600 degrees centigrade temperature. Just imagine there is a fire in a building or in a hospital, and nothing can work. These belts can we can put in the this fire, they will not deform. Even fire blankets are there, which will safely protect the person without injury actually. So these are the very good things. Even carbon, I am not just covered in slide, but I am telling you carbon. Suppose in US, many times there is a problem of this snow. Even roads are with the full snow. Now people are doing the, or institutes are doing the experiments. With this carbon, we pass some current like carbon brackets or like blankets or like other blankets. The snow can be solved. So you see in snow total US sub portion disturbed in working. So this can be solved actually by these technical textiles. Plus there are many innovative uses and things are coming up day by day. So for an entrepreneur, it is a very good thing to learn these subjects and to choose a business and uh, to find their insight and start the business as an entrepreneur. So he or she can sustain the things and they can give the jobs to the several person. So now, if you see, IIMTs can also give some courses which can let you know about the technical textiles. Our institute can give the idea how to decide and procure the raw material, industrial fabrics, certain calculations and conversions, how we make the cost effective manufacturing. There should not be a very less waste. If we reconcile, profit margin should be more. waste should be less. Application uses of the technical textiles. They will include a subject. If somebody wants particular subject or particular of technical textile or any textiles, we can design for them. Preparation of project proposal, as I told you in the beginning. Then training of the composite manufacturing techniques. So that type of trainings can be given by IIMTs, which are job-oriented courses. Now, if we conclude with this lecture, technical fabrics can be developed on the particular type of machine in knitting, weaving, non-woven, belt, and ropes, nano fabrics. Then 3D. Then what we have seen, if you want to make particular fabric, you have to choose the machine. So during establishing of the business, we have to find the machine which can run many things by less investment or without investment. So according to demand, we convert the machine in the requirement. Then mostly loom are equipped with the microprocessor based controls. See, earlier conventional loom were there, so they were operated manually only. Now they are the good microprocessor based controls. We have the microprocessor based control training also, how to see the efficiencies, how we can increase the efficiency of operator, how we can increase the woven quality, then how we can increase the production with quality. Quality is very important. So these we can do some calculations. We have the tailor ready-made calculations for entrepreneur. When need has come, just changes the some in microprocessor some keys, and you will get the ready-made program for that. So that way we can do actually. So microprocessor has brought a very good revolution in the industry and looms and other machines. Now, the last but not least, I feel privileged to say you, if somebody is doing the course of entrepreneurship or doing entrepreneurship, maintenance is very important. Old machines doesn't mean they will not give the efficiency. Only how we maintain the machine give the conception of how much we are going to give the efficiency. New machine, if we will not maintain, it will give deform, it will give poor quality. And very old machine, 40 years old machine, if we install an entrepreneur, second machine, used machine, no problem. If we are maintaining them properly by lubrication, settings, oil, grease, everything, handling, I can say you 95% efficiency, 99% efficiency is possible on the old machines. So thanks friend and students, and for any question, you can type. Or anything again you want to